Hello, can you hear me? Anyone out there? I'm out there. I'm here. There I am on delay. Hello everyone, it is February 1st, 2024, and you know what tomorrow is? Groundhog Day, which means we're going to be doing some groundhog predictions. Yeehaw! If you're not over on Twitch, you should go there because I'm streaming. You can see the names down here. I changed it to Rob Codes Live recently, and that's where you're going to be able to chat with me. So don't try to chat on YouTube. That is a no-no. Go over to Twitch. And no one's chatting anyways, so what does it matter? Hey, let's switch this over to my magical green screen room, which is this. Hey, looks pretty nice, although my hand disappeared. But yeah, this is my new office. What do you guys think? Pretty nice, huh? Spent a lot of money upgrading this last few weeks, and this is what we got now. How about we go ahead and stream? Let's test the chat. Should appear somewhere. Oh, it's not. Oh, it kind of does. You can kind of see it like right here. But that's fine. I think in the next screen, it'll look better. Okay, yeah, so here we are. So let me know if you're out there. If you're not, if no one's out there, then that's fine. But what we're going to do is we're going to go onto this site Kaggle and maybe do some Groundhog Day predictions. Love from Arlington. Nice. Arlington, Virginia. Looks amazing. Thank you. Appreciate that. VA, Arlington, Virginia. That's, I know where that is. Nice. So let me know what you guys love from Michigan. We got people in Michigan, in Egypt. Oh, just, you know, Virginia, Michigan, then all the way over in Egypt. Awesome. What time is it in Egypt? Look at this. Groundhog Day. Forecast and temperatures. This is a data set that exists already about this. So if you're in Egypt, you might be asking yourself, what is this guy talking about groundhogs all about? What's all the deal with groundhogs right now? That's because in the United States of America, it's probably the most popular holiday. I think the most popular holiday in the country of the year is this holiday called Groundhog's Day. We've been voting year after year to get this to be a national holiday. I hope it will be eventually, because honestly, the kids can't stop talking about it. It's a holiday where there's one main groundhog, but there's also a bunch of other groundhogs. What we do is we take the groundhog, we take this animal that has no idea what's going on, and we tell the animal that we fake like the animal has decided if there's going to be more winter or if we're going to have spring come early. And in Punxsutawney, Pennsylvania is where the Punxsutawney Phil lives. He's the main one. And there's actually a movie about that. And a lot of stuff repeats in that movie. Anyways, this happens year after year. And we're going to try to predict it. Let's try to predict what Punxsutawney Phil's going to do tomorrow. I was wondering, does anyone out there know, does Groundhog Day actually have, is there like a betting line that you can do it? I'm not a bettor. Thanks for the amazing explanation. Thank you. We missed you a lot. Great to have you back. Learn evenings. Please continue to hold these sessions. I'll try my best. Still not a holiday in DMV. True. Sleepint, but I popped up. Hi from France. Hey from France. Welcome. Howdy. Okay, so I already explained what the holiday is, okay? The most famous holiday in all of America is this Groundhog Day. And we got to predict what the groundhog's going to say. So, groundhog betting lines. Let's see if this comes up with anything. I think you can bet on this. Seems like a really easy way to like. This is kind of cheating that we're looking at this. Will Punxsutawney Phil see his shadow? Let's look up Wikipedia just to explain this better than I just did. Okay, Groundhog's Day is tradition observed in the United States and Canada. Canada steals our traditions. This is ours. Okay, Canada, we'll let you in on this one. On February 2nd of every year, which is tomorrow, unless you live somewhere where it's already today, it derives from the Pennsylvania Dutch superstition that if a groundhog emerges from his burrow on this day and sees his shadow, it will retreat into its den and winter will go on for 6 more weeks. If it does not see its shadow, spring will arrive early. Isn't there like a certain number of weeks? Whilst tradition remains popular in the 21st century, studies have found no constant association between a groundhog seeing its shadow and the subsequent arrival time of spring-like weather. How did they know if it saw its shadow? What are they basing this correlation, this lack of correlation on what this guy says? What this guy says, or are they actually asking the groundhog? That's my question. Because I bet if you ask the actual groundhog, then you'll know. Today for me it's 4 a.m. Friday. So Woon, what I need you to do, since you're saying it's already Friday for you, can you go out and look for a groundhog and ask it what it sees? I guess it's 4 a.m., so it's not even light there. So I'm assuming there's some data about this. This is a data set on Kaggle. The thing is, it's 7 years old, so this is completely out of date. But let's create a new notebook on it, and then maybe we can scrape some data online. It's Groundhog Day 2024, baby. I'm excited. I'm excited. Can you tell? My text is huge. I kind of feel like if I had prepared this better, I would have memorized everything I've said into the stream at this point, and then I would repeat it and act like nothing was weird. By the way, I'm participating in my first Kaggle competition. This is Himitsu, a private one on syllaba fairness, where you have to predict 6 labels for each picture via CNN. First attempt gave us 63% accuracy with no bias. Hope we'll get up to 80% soon. Nice. Good work. I think groundhogs are only found in the US. Well, that's why you have to have your own groundhog that you bring with you to whatever country you're in. And then, well, I guess then it's going to tell you the weather in that country. So there are holes in my whole plan. Man, how can we... Next year, we need to figure out how to get a groundhog to tell us what it's gonna do the following day. We need to invest time in learning how to speak to groundhogs, and then we can bet on it on this website that has odds that it will not see its shadow. Wait, it will not see its shadow, which means it will be more... I'm always confused by that. So, okay, so they're betting it won't see its shadow, so we're going to have early spring. I like that. I like that. Let's go ahead and read. So what we're going to do is we're going to start out by looking at the historic groundhog data, 7 years old. And then we're going to try to bring in our own new data. Right? Groundhog. Why is this not autocomplete? There we go. Are there any libraries which are better and more efficient than Optuna for fine tuning? Not really. You could just do like a grid search, a random grid search. It kind of depends how big your parameter search is. What's up, Gazin Whitoben? Welcome to the chat. All right, so this is our data frame. It's where our data exists. Right? We're going to take this data frame and we're going to check it out. Punxsutawney Phil. Okay, so they have different... No. Oh, it goes all the way back to 1886. You got to be kidding me. So how can we plot this? Group by... I guess every year is going to be independent anyways. Let's set our index to year. So they have the February average temperature in the Northeast, Midwest, Pennsylvania. And then they have the March temperature. Okay, so this is forward looking. What if they have the forecast? So let's just look at a value counts of this Punxsutawney Phil data. Also, let's look at a tail of this and see what the final year. So they had what, 1901 to 2000. Oh, this is the average temperatures over that time. But this data only goes up to 2016. Do they have any information how they created it? Citation. Full shadow. Oh, there's partial shadows, I guess. No shadow, no record, partial shadow. When did partial shadow occur? We're going to query. Oh, this is why I hate having spaces in the column name. So we're going to have to... I'm not sure if this is going to work because... That's a column name. Let's go ahead and do it this way. When Punxsutawney Phil equals partial shadow, and we'll find that row in this data set. Punxsutawney Phil partially saw his shadow in 1942. Your username is German, basically means high up there. Hi up there. Someone asked, wait, does ... / fill in the whole path to what you write then? No, so what this does is like PD read CSV. So I know that the default folder on Kaggle is a directory up one, and it's called input. So it should, in Jupyter, tab completion when you're looking in a file directory is actually really handy. So this actually lists all the files here in the input. Then I know there's a Groundhog Day folder. So all I'm doing is hitting tab and enter, and we're getting this auto completion. That's what it's doing. It's really has nothing to do with this ... Like in this local directory, if I make a file called test.txt, and now if I ls here, so these exclamation points are letting me run bash commands in Jupyter. So now there's a test.txt file in this folder. If I type in test with a tab, then it will autocomplete to the test.txt. So that's what I like about Jupyter when you're doing exploratory stuff and you're trying to look at files and directories and stuff. The root folder is ... I mean, not necessarily. It's just, right? The ... backslash is just going up one directory. My root directory is going to be this tilde and then backslash. So if I did root directory is this. It's like where my bash rc is. And that's actually in /root source, I think. Yeah. Root source. Anyways. So Punxsutawney Phil had partial shadow on that day. What if we go to the Wikipedia page for Punxsutawney Phil and we try to pull it from here? There's got to be a table. Hey, Himichus, thank you for subscribing. Thank you. Where's the data? Okay, so where's the data? Because local statistics. Oh, there's a whole Wikipedia part about statistics. Punxsutawney Phil statistics are kept in the Pennsylvania's Groundhog Club. Shoot, I forgot to apply for the Groundhogs Club. Phil has predicted 106 forecasts for winter and 19 for early spring. I never knew the odds were that bad. Wait, 19 for early spring, and yet the books are saying he will not see a shadow? So the books are cooked. I don't know how to use that term correctly. Come on, Punxsutawney. All right, so let's read a little bit more of this. 1 year he had a partial shadow in 1942. Hey, we could have written this Wikipedia article because we were exploring this data so well. There were 10 years where Phil's prediction was not recorded, all of which occurred in the 1880s and 1890s. I honestly didn't know this went back this far. This is like one of the longest traditions of data, of significant data. I'm making statements that I don't know are true. There has been 1 year where the event was canceled due to World War II. Okay, give him a pass. Most assessments of Phil's accuracies have given an accuracy lower than would be expected by random chance. Storm Facts Almanac gives Phil an estimate of 39% accuracy. Phil, why are you so bad? But we want to predict what Phil is gonna guess, right? Some other people give him a 40% for the 10-year period preceding 2019. The Farmer's Almanac, which itself has been known for forecasts of questionable accuracy, gives an assessment of exactly 50% accuracy. Why are all these accuracies, like, shouldn't this be pretty straightforward if he got it correctly or not? Is a question whether if they consider the early spring or not? RCS page, what are you dabbing in, Rob? I am dabbling in Punxsutawney Phil data. We're looking at We're trying to see what Phil is going to say tomorrow. Phil's long-term analysis temperature high-low predictions were 70% accurate. Whoa! There's so many different accuracies around there. Some people are saying 70%. Some people are saying 39% accurate. What is it, Phil? Canadian meteorologist Cindy Day has estimated Nova Scotia's something Sam accuracy rate of 45%. Who are these Canadian groundhogs? This is not a thing. Part of the problem with pinning down accuracy rate for the groundhog is that what constitutes as an early spring is not clearly defined. Assessments of the accuracy of the groundhog, such as Staten Island Chuck, use objective formula. In Chuck's case, a majority of days that reach 40 degrees Fahrenheit in New York City between Groundhog's Day and March equinox. Okay, so they actually are very particular about how they define this early spring. Where's the data set? Okay, so there's a data set for the Nova Scotia's groundhog guy. But what I want is Punxsutawney Phil. Groundhog-day.com, the leading... What did it say? The leading Groundhog Day data source. I think we found it, folks. Oh my goodness. It goes much deeper than what we thought. There are so many groundhogs. There's more than Phil. Look at this. How are they already reporting? This doesn't make any sense. Oh wait, this is 2022. That's how they're reporting. Punxsutawney Phil hasn't. Why is Benny the Bass reporting for early spring? That is ridiculous. Is there an API for this site? Okay, so it says something about structured data. Oh my goodness, there's an API. We're going to be able to do it. The Groundhog Day API returns all of North America's prognosticating animals and their yearly weather predictions. It's critical infrastructure you need for your next multi-billion-dollar business venture. Whoever made this website gets me. All right, we're going to learn how to use this API. Hi, Rob. Who's saying hi, Rob? Hello, people. All right, we're going to use... I like how they call it. Should be enough to get you started. There's an open API schema available if you need enterprise level documentation before rolling out your GAAP, Groundhogs as a platform. This person is funny. There are 3 endpoints. Groundhogs, Groundhog Slug, and Git. Adding / modifying data. Updating data is possible, but not through the API. All right, so... Okay, so let's learn how to use this API. So we're going to get more groundhog data through the Groundhog Day API, official API. All right, so let's import requests. And we're going to get this response. And in it, there should be some content. Not history, headers. All right, this is the header we sent when we requested the response. Let's see the JSON response. Expecting value in line 1, column 1. Okay, so JSON's not working. What is it, content? Okay, so we have all this messy content. What's this messy content? This API is kind of gross. It's just giving us HTML. Oh, that's because we're not hitting up the correct API endpoint. Okay, so we want to do /API v1 /groundhogs. All right, so this should give us JSON. There we go. It just gives us everything? No way. Morning, dabbling in groundhogs. Yeah, I wish it was morning because then we would know what the groundhog's gonna do. I can't wait. It's the biggest day of the year. By far the biggest day of the year. All right. They have details. So if the API gives us all this, can we convert this into... So we only have groundhogs. Even though... Okay, so we created a data frame from this, and it looks like we have a bunch of unique IDs, one for each groundhog. We only really care about Punxsutawney Phil, but let's give the other ones a chance. Then we have the coordinates of where they are. Source, a contact in case we need to reach out to someone at the groundhog. Is groundhog. Taxidermied groundhog is on here. And then predictions count. And then in each of these actually has the predictions. All right, so what's the difference between this? And so it looks like if we did it this way, if we looked at the endpoint like this, if we got the groundhog /slug. So a slug might be Punxsutawney Phil, and we look at the response from this. Right? A 404. Why do we get 404? V1 groundhog /slug. Did I get your slug name wrong? Maybe this part of the API doesn't work correctly. Groundhog. The groundhogs does work. Strange stuff. What are we doing here? Why does it stop playing? Want more music? Wait, I have this. Just need to log in. All right, so we're going to make an up-to-date. First thing we're going to do is make an up-to-date groundhog data set. We're going to make a metadata data set. We're going to make a hogs data set, and then we're going to make a I guess metadata will be the hogs. And then the predictions will have a raw data set per slug name. Let's go ahead and do that. Should we? Shall we? What I'm going to do is I'm going to create a new notebook that has no relationship to this other one. It's called Groundhog Dataset Creation. We're going to import pandas. Actually, let's import requests. Let's import pandas and NumPy. The nice thing about this is we're going to use our API so we can productionize this to run once per year and pull the latest Groundhog info. All right, so we're going to do it just like we did before, where we have, where was it? Oh, did I just, I guess we can just write it. Requests dot get. We're going to get this URL. API v1 groundhogs. Gotta remember my H and my hogs. We have a response. Then we're going to turn that into JSON. And then we're going to create a data frame with this. Huh. Oh, yeah, we want to just grab the groundhog's response part of that. All right, now we've created our hogs. The thing is, we don't necessarily want this column, which has all the predictions, as another JSON list within this data frame, right? So let's go ahead and drop predictions and axis equals 1. And we'll go ahead and save our hogs to CSV. Index is false. We're going to save it. So that's our hogs. That's everything we need to know. So we could plot, like, let's do, let's plot each of these on a map. What do you guys think? Hey man, surely not bigger than Festivus. It is bigger than Festivus. Groundhog Day is the most epic day in the US calendar. All right, so this is saying we could use Folium to make our plot. So we can make a Folium map like this and then use our hogs. So what we really want to do is take our hogs and split this by the comma. So now it's like a list, and then we could take the first value, which is the longitude. So we're basically splitting this into I think longitude first, longitude, and our latitude will be next, right? We can always plot this if it's wrong. So then if we take the hogs and longitude, column, and we do values, and we just take the first one. So we're gonna plot this first hog with our longitude and latitude and zoom start. I'm not sure what. Wait, this should be map location, not log art station. All right, so zoom start is 12. Then how do we watch this? So I want to do it from this into a Jupyter notebook so we can see it. APL should be groundhogs/slug plural groundhogs. Did I do groundhog before? No, but see here it's groundhog/slug. I mean, at least the API says it's groundhog/slug. Maybe this text is wrong. You're right. You're right. Because even though it says groundhog here, it's a typo because there should be an S there. Because yeah, when I do groundhogs/Wary and Willie, it looks like that gives us all of his info. All right, how are we going to plot this? Now it's saying to use GeoPandas. All right, longitude. This needs to be uppercase. All right, so what we're doing here is we're using GeoPandas to create a geodata frame with the latitude and longitude and latitude. And now we've plotted them all, but it's on this weird map. And I think I did have this wrong, right? So latitude was first and then longitude. But it looks weird. So I'm not a big fan of the GeoPandas. What if we tried this? All right, latitude and longitude need to be lowercase. And the pop-up's gonna be our slug. Let's make this slug. Cannot convert to string. What? Why is it trying to do that? That doesn't make sense. So it's saying that these are strings, hogs. Maybe I need to make these numeric. Okay, so when I did this splitting here and I took it out, I'm gonna do 2 numeric first. This may help. All right, what do we got here? What do we got here? We got a bunch of hogs. Okay, it looks like Folium works a lot easier out of the bat. Off the bat. Let's go ahead and delete this GeoPandas stuff because we don't need that anymore. We're going to say here, extract groundhog locations and plot on map. That's what we did there. We need this to initially zoom out more, right? Zoom start as a 3. Maybe a little bit more than a 3. And what I'm going to do here is save this version, run it all. Now, granted, this is going to pull from the API endpoint. We aren't actually using any data set that we've saved off yet. So next year, if you guys are watching this in 2025 and you want to recreate this, you should, unless they've taken down the Groundhog Day platform, maybe the government's going to like strike this down. It will be up next year. So what I'm going to do is make sure I share this, go to the viewer, settings, make this public. Is there a groundhog emoji? There's no real groundhog emoji, is there? There's just a squirrel. I should add it to it. All right, public. I was going to add it to the title because that's always fun, right? Adding some emojis. Save these changes. Now, all of you out there, all million of you watching right now, if I put this here, how did I get the map? Is it the Folium library? Yes, I use the Folium library, which allows us to plot these on a map and see the name. So it's just going to show us. So let's dig a little bit deeper into the Folium map library and see if there's anything additional we want to do. Because we could add like the name, the official name, the city name. Trying to think what else we would want to show. Because like in these examples, oh, you can click it and go to URL. Oh, clicking it will tell you the name. So yeah, super customizable what we could do with this. Can make the icons different if it's not a groundhog or is a groundhog. Yeah, so like let's look at this. This marker object, we could make pop-up tooltip icon. Could we make the icon an image? Icon cloud. Oh, okay. Okay, so there's a bunch of different icons we can choose from. So we can make this the row. Is groundhog int object has no. Okay, so that's just a single row that we're looking at. So this will make them all clouds. I don't know if that's very helpful. But I could, for instance, yeah. I mean, there's a lot of different ways we could add these points. We could make them green. If it is a hog. What's this column name? Is groundhog. This equals 1. And it looks like we overrode them with cloud. So we need to make this if it's not equal to 1. All right, so all the non-groundhogs are now clouds. But why aren't these green? Icon is green. Oh, color is green. There we go. So it looks like the groundhogs are very East Coast and Canada centric. Do you see this? We're seeing a pattern to the groundhogs. Does a taxidermied groundhog count as a groundhog? I think it does. That's a good question, Lopta. Let's look at the hogs and see this taxidermied groundhog. It's active. I like how it says it's active. It's not that active if it's taxidermied, right? Is groundhog? Oh, no, they do not consider that a groundhog. They consider it a taxidermied groundhog. Yeah, so if we look at the types, if we look at the type of things that we have, they're called prognosticators. I don't know if I spelt this correctly. I think I did. So a prognosticator is a forecaster, a diviner, a prophet, a soothsayer, or an oracle. So that's what these are. They're oracles. So if we look at our different prognosticators, we'll make this a horizontal bar chart. True. All right, mostly groundhogs. Mostly groundhogs. Count by prognosticator type. So we got a lot of groundhogs. Then we have a few taxidermied groundhogs, of course. Person in a groundhog suit. There's over 5 people in groundhog suits that make predictions. Okay. There's some plush groundhogs and, of course, plush yellow-bellied marmots. Plush means it's just like a doll, right? Furry futures. I don't see that one. Okay, you're just saying that? And, of course, an Americana chicken. What is this? What is this? And why is there taxidermy groundhogs? Like someone has multiple groundhogs that they're using to predict? Hey there, question mark. Hey, what's up, David J? We're just looking at some groundhog data. There's one that's a cat. All right, so now what we're going to do is let's explode out predictions from each prognosticator. All right. I'm not sure why I called this hogs. It's really confusing because hogs are like pigs. I should just call them Prognosticators. So I'm going to put this with the P, Prognosticators. As I save it as a CSV, it'll be Prognosticators. For the data frame, we'll leave it as hogs because it's easier to type. All right, so if we go through these hogs, oh yeah, I dropped the actual predictions column. So what I'm gonna need to do here is re-pull this response, or actually take this response. Call this progs. We can iter rows because it's not gonna take that long to get through. How many of these prognosticators do we have? Not even 100. 75 prognosticators. So I think we'll be fine. And we're gonna break at each row, and then we'll have this D data for the prognosticator. We'll take their slug. No, so we'll take their predictions, make a sub data frame based on this. Right? So now we have, for each year, if they saw their shadow or not, and we even have some details. Got it? If you feel me, type something in the chat. All right, so this is going to be our prognosticator data frame. And then we're going to assign the ID name to it. Right? So now it has the ID name. Something. Okay, wounds around. Thanks. And basically, we want to kind of just take the ID. ID and slug. And that's good enough. Why does it have current prediction? Okay, so that's a link to an old site. Oh, even the URL of the image isn't showing up? You don't get it? It's a marmot theme pun. Oh. 1 day until Groundhog's Day. Did I mess up my... Okay, here we go. Here we go. We have our map. We have our map of our marmots. Which is the closest to me? There's a DC, a Potomac Phil? What the... What? He couldn't even think up his own name? Potomac Phil? Okay, so we're going to look up each of these. We're going to take the ID, and we're going to take the slug. And can we make this to dictionary? And then can we assign this way? Like this with 2 stars. Yes. So now we have, in this data frame, we have the marmots, the predictors ID, their slug name, and then every year and their prediction. So then let's order this. So let's order this as ID, slug, year, shadow, and details. And then we'll save this to a CSV with the name of the slug. .csv index equals false. Alrighty. And now if I ls all the files here, we have Punxsutawney Phil's CSV here. We could read that. this way. Also, we can do like a stacked data frame later. Yeah, I think once we get these all written out, let's just make sure this works fine with no issues. No, why did it bring me way up there? So I just want to tab this over. And boom, there we go. Now if we ls-l here, look, we have one CSV for everything. Oh, hits Mitsu's leaving. All right, time for me to go log out for the night. Good stream. I'll hope you see you soon, Rob. Yes, I'll be doing more often if this is fun for people. What do the double stars do in the sign? So when you have a dictionary like this, let's just say this is a dictionary, right? When I do a double star before it, it will take a dictionary and it will instead use it as an argument value pair. So I don't know a better way to explain it other than if I then have something that takes in like my function and let's define a function called my function, and it takes in an ID and a slug, and it prints the ID is an ID, right? The slug is and then it does slug. So if we test out my function, and let's say it's 5 and it's Rob Groundhog, right? The ID is 5, the slug is Rob Groundhog. Now if I have this dictionary, this example dictionary that looks like this, by putting 2 stars in front of it, I can call this my function. Right? And it will take the keys of this dictionary and make it into keyword arguments. I used to have a computer that used double stars for exponent because character set stack. Wait, so it is like in Python, 5 * 2 is 5 raised to the power of 2. Is that what you mean? It pulls the values without the keys? No, so it takes this dictionary and it will feed it into this function as if we had done this. Like we could have also done my function ID equals example dictionary ID. But then we also need a slug. So we could have done example dictionary slug. And this gives us the exact same response, but we had to type in all this stuff. So like this is just a shorter way. Long way. Short way. It unpacks things. Yeah, that's a good way to say it. That's a better way to say it. So. Yeah, so I'm looking it up now. It says the star operator is used in a function call to unpack a dictionary into keyword arguments. So unpack is the word that I was missing there. It means that each key value pair in the dictionary is passed as a separate keyword argument of the function. So yeah, so it takes this dictionary. So just think about it when you're writing a function and you're passing through a bunch of different keywords. Instead of writing it like this, where you have to assign each variable to the value within that dictionary, you can just, it's handy to just do ** and get it unpacked. I hope that helps. Hey, we have someone in chat with a name I cannot read, but hello there. Thanks for chatting. Hope you're doing well. Okay, so that was just an example, but now we have all these data frames, right? Let's plot the prediction every year for wait, so all right, so I'm going to do it this way. So we save off the CSV this way. But let's also try to how are we going to do this? If we want to create one big data frame with each of their predictions per year, some of these guys have only been around a few years, but we can actually store off all these data frames each time we iterate over to a list. Then can we just concatenate them? Yeah, that kind of works because now they're all just stacked on top of each other. And this is like our df all. Let's reset this index and copy this. Is it bad that I don't even know what a data frame is? No, that just means that you have a lot that you can learn. That's exciting. All right, so we got Punxsutawney Phil here. And if we, so now we can do stuff like, we can see the number of predictions by the different predictors. So what is this? Octorario Orphy? Who is this guy? Octorario Orphy turns in his 2023 Groundhog Day predictions with photos. So this is not a real groundhog. But it's been going on for 99 years. He's about to have his 100th guess. So you're going to predict what Phil says? Yeah, first we're just pulling the data. We're just pulling the data in. So data frame all. Now if we group by the slug and the year, and we take the prediction, I think it's called shadow. And we unstack it maybe. Then we can kind of do, maybe this is the wrong way though. But now we do have predictions. We have predictions per guy, per predictor. But we kind of want to sort this by how many the predictor has. So let's look at this way. Value counts. I did that false again. It should have been true. Now we can actually visually see who has the most predictions. So we might want to threshold this. Like if you don't have more than 5 predictions, you're not going to be on our plot, dude. You're just not there yet. Let's import matplotlib. Like some of these are imposters. Some of these groundhogs haven't even been around a year yet. Those are imposters. Come on, groundhogs. All right, so back to this. I imported matplotlib. Number of predictions per. So Unadilla Billy, Heavens Wildlife Harvey. We gotta just get these out. Does one need a GPU to attempt this kind of highfalutin data wrangling? No, not at all. For this, no. But we did do on the last stream, which was like a month ago, but we did show how you can use CUDA and pandas together to do some really fast stuff on a GPU. But data set of this size, tiny, absolutely tiny, no reason to use a GPU. How could you tell who's most accurate? Now that could require us to really step up our game. We could try to pull a weather API. Could we try to pull a weather API based on the latitude and longitude of each one? But the problem is we read about in the Wikipedia page is that most of the discrepancies in the accuracy of these prognosticators is that it's not clearly defined what exactly it means to have predicted correctly. What constitutes an early spring is not clearly defined. Assessments of the accuracy of other groundhogs such as Staten Island Chuck use an objective formula. So we would have to figure out a formula. We'd have to pull the data in, figure it out. Pirate weather? Oh. Is that a API for getting weather? Hey, maybe we could do it. Is there synthetic any way to do feature engineering with multiple table in a database? Our team is trying to do feature tools like this. Not so good so far. Yeah, of course you can make features based on multiple tables, but you'd have to have some connection between them, right? So, for instance, each row in this might be a prediction per ID or per slug, per groundhog. But if you had some other information about them in a different table, you could like left join on that and then make that a feature and make it like their prediction per average or something like that. All right, so we got all these. By the way, can you guys see this? Groundhog dataset creation. If I put this in the chat and you click on that link, hopefully you guys can see this. Give it an upvote if you have a Kaggle account. All of this code should be here. I haven't saved it in a while, so the latest version is just saving. All right, so let's make a little heat map of what they predicted, right? So let's take this and use it to filter only to the the predictors with, let's say, more than 20. More than 20 predictions. Then we'll take this index. I could do 2 lists. Let's call these good progs. Good prognosticators. And let's query where the slug is in the good progs. All right. So now we only have the 20 guys who predict often. None of them have predictions, or I don't think most of them have predictions for 2024. But let's import something like Seaborn. I always like this. Seaborn. Heatmap. See what this looks like. Maybe we could also sort it in the... Like, we want to sort the columns in this good prognosticator's order, because that's in the order of who predicts the most. We'll have them all the way at the left. Yeah, there we go. Now Phil is all the way in the left. So Phil, as we read about before, more often than not sees his shadow. Phil has predicted, most of the time he doesn't see his shadow, so he predicts an early winter. So that's why we see all these ones. Wait. All right, shadow should be a 1 if he sees his shadow, right? Even I learned what is a Groundhog Day. Learning new things is exciting. Nice. Yeah, this does look funky, but okay, some stuff is jumping out to me. Like maybe the 1s and 0s are flipped for some of them. So he mostly predicts winter. If he sees his shadow, that means more spring. Okay, so he sees his shadow, he retreats. Okay, then that's why it's a 1. Okay, 1 here means winter, more winter. 0 means early spring. So who is this guy? General Brigade what the General is a groundhog considered the main weather prognosticator of southern United States. Oh, he's Georgia's. So that makes sense. He's going to predict a lot of early spring because he's in Georgia, where it's warmer, where it's hot outside. Could we on a map show them? Yeah, you're going to have to cross-reference with weather forecasts. I think you're right. Does this plot make sense at least? Like what we're looking at here is a row per, maybe if I do it like this, it'll be a little bit easier. Maybe that's harder to see. But each row is a different predictor. Punxsutawney Phil has predicted from way back in 1886. No one else has gone that far. But then you have all these other guys who came along, tried to, you know, get on the coattails of Punxsutawney. And some of them predict more. Black means that they're predicting a 0. Maybe split it from 1s and 0s. Could I do maybe map 0 to spring? 0 is early spring. And 1 to winter. Long winter. Let's see if this works. Could not convert string to float. Yeah, it doesn't like it because I need to... I have null values. Are we using 1s and 0 because the language doesn't have a Boolean type, or is that because the API provides? It's what the API provided. So yeah, I could make raw preds. Well, we're using 1s and 0s also because we don't have, if it's a Boolean type, like if we take Punxsutawney Phil and we take this column and we do as type bool, the problem is that it's gonna take our null values and make those true. But it's actually a null value. It's a missing value because he didn't have a prediction that year. So in this plot, if we do that, then you won't really get the idea, or you won't be able to see that some of these guys just didn't predict for a while. Trues are harder to count than ones. So a Boolean wouldn't work with null values. Yeah, exactly. So a Boolean value is just one bit, right? Either it's basically only 1s or 0s, but with having a floating point number, you can have a null value. So, I mean, yes, this could be prettier, but let's just try to move on. Let's try to power through this. What will he predict? So, can we pull the weather? Let's pull historic weather using longitude, and might as well try to get like the full date, right? So is pirate weather the best way to do this? Let's ask my little helper over here how to do it. How can we pull daily weather forecasts in Python using the pirate weather API for a long location? First thing I need to do is get API key. Is it free? Build free per month. Okay, I can handle that. Quota 10,000. That's fine. It's better than nothing. I need to create a unique. Oh man. Oh man. Let's see if there's a free. I'm asking if there's a free version that does not require an API key. So there's this openmedio.com. Let's see what this is all about. See what this is all about. Free weather API. OpenMedio is an open source weather API that offers free access, non-commercial use, no API key required. Start using it now. This sounds like exactly what we want. All right, Lopta's leaving. See ya. Thanks for hanging out. All right, so let's try to see if this little code base works and see if it lets us pull the weather forecast for latitude. Okay, so this is a forecast. This would be a fun thing to have as like a Kaggle competition if people predicted the day before Groundhog's Day for all of these different prognosticators to see if they're right. All right, so it failed to retrieve data because we're going to actually go through our latitude and longitude by prognosticator. So this should be this. Right? And then we'll break here. Hogs should have latitude and longitude. Oh, we did that up here. We did that up here. We extracted latitude and longitude up there. So I need to make sure that I'm using that hogs. I think we renamed it when we pulled it the second time. All right, so here we go. Now we have a forecast for this historic values. Okay. What if I want... What if I want historic data? Okay, so this... Let's see what they do for historical data. So we can do a start date and an end date. Oh! Start date and end date. Hourly temperature. So we want to, you still open medio.com. And see how this looks. So this is getting forecast, which maybe we could use to help us in our prediction. I didn't know you go live. I need to turn my bell on. Yeah, Antonia Williams on YouTube. Yes, you do. Thank you. Okay, so apparently we can get the historical data like this. Latitude, longitude, start date, end date. So basically what we want to do is when we loop through each of these, we should get the start date. We basically want to go through DF-all, group by the slug. Oh, but this doesn't have latitude and longitude. So let's pull this raw hogs response. And let's ignore this dropping of the predictions. Ignore the dropping of the predictions. Also, might as well add this longitude and latitude before saving it off. Still got our map here. Let's get our historical weather. Oh, shoot. For this. And it does. Oh, man, it's going to freeze up this page because it's so much weather data. Okay, so we don't want to actually print this. What we want to do. What we want to do is choose a date range from January and February for each year that they've predicted. So basically we'll go into this hogs. We'll go in through each of these predict for ID in hogs iter rows. Break out after this. We have latitude and longitude. We also have predictions. So then we'll take predictions. Make a sub data frame. We'll drop NA for the subset of shadow. Because we don't care about the years where he didn't make a prediction, right? And then we'll say 4 year in pred years. And we'll break here. So now we have the year. And pred years year. All right. Make this an F string. All right. Pulling for that guy and year. All right, so this isn't right, because why would it do... Oh, because I'm breaking out. So this is just going to be the first year of each one. All right, so now we can see what I have done is we're running through each of these Prognosticators. Punxsutawney Phil started in 1887. So we're running through each year, right? And then this next dude, and all the way down. And then there's some of them that only predicted in recent years, so we're not going to want to pull their weather data for those years where they didn't exist. And yeah, and then we're going to actually pull down their weather data. So if you're just joining us, what we are doing here is we're doing a deep dive, because tomorrow is Groundhog's Day, into some groundhog data. Now, we all know Punxsutawney Phil. He's the man. He's been predicting for like 100 years. But you got some newbies on the block, and they're also predicting. And we're going to make a data set where we have their predictions and the weather patterns and see who's the best at predicting. And also maybe make a prediction ourselves about if you think it's going to be more winter or not tomorrow by Punxsutawney Phil's standard. By the way, what's the votes out there? Do you guys think it's going to be a early spring, or do you think we're going to have a long winter? If you think it's going to be early spring, put an S in for spring. If you think it's going to be a long winter, put a W in the chat for winter, and let me know what you think. I know everyone's so engaged right now. All right, so now we need to use this function to pull the weather data. Ooh, I'm seeing some S's. I'm seeing some hopeful S's. I'm with you. So what we need here is the latitude and longitude. Now the start date. This should be our year. And then I guess we should do February 1st to the end date, which is going to be our year. And then actually, let's do January 1st so we get the month prior. And go into April 1st, right? Of that year. Only that specific year. So, if this works correct, we should have Punxsutawney Phil. So, in that latitude, longitude, the historical weather data for that area. But it looks like we got nothing. Maybe because it's so long ago that we're getting returned none. Remember, see, it didn't even fail to respond. It's giving us a JSON response of none. So now we're running this through, and it looks like it's still no weather all the way up to 1940. Oh, wait. So it ended at 1940. So it looks like in 1940, we do have some historical weather data. Hourly. I'm surprised that they stored this hourly back that far. So all we have is the temperature. I really want to learn this stuff, but I don't understand anything you're doing right now. It's okay. We'll learn together. I hope it's a long winter. The snow has been a joke here in Colorado. I feel you. We went snow tubing with my family. Well, this isn't in Colorado, but in Maryland. Actually, it was West Virginia. We went snow tubing, and it was raining, and it wasn't that snowy. But I still want spring to come. All right, so we're pulling just the temperature. Is there something more we could pull? This is 2-minute temperature. Let's see what this historical data API gives us. Read the docs. Historical weather docs. We can get 2-minute temperature, humidity, rain, snowfall, apparent temperature. Why not get all of this? That's the thing. Okay, so I actually think, what do you guys in chat think? Pulling Groundhog data hourly, or should we just go ahead and get the daily data? Because this will give us like the average temperature, the min, max. Oh yeah, and then it's telling us about max wind. We want all this. All right, then we can get the Python for this. These are all the daily codes that we would want. All right, so going back over this. We're going to call this daily codes. These are all the codes we want to get for daily historical data. Just grabbed it all, right? And then basically what we want here is oh, they have their own OpenMeto Python package that we could have used. But let's go ahead and do this. Daily, we're going to put this just hard-coded. It's kind of bad, but as these daily codes, comma, join. Now we have all the different weather data codes that we want. And let's see if we could pass this daily codes. And this is going to not have hourly. It's going to have daily. Let's give this daily codes. Yeah, so this example is not going to work anymore. But if we did provide it, actually, let's go like this. If we did provide it the daily codes, failed to retrieve. That's because we have to separate this like this. Ah. Now we have weather data. That's going to have, oh geez, all this daily data. So if we look at the daily, make this into a data frame. Boom! For this location, we have all this information. Sunrise, sunset time, shortwave radiation. Maybe the groundhogs are just good at predicting the short wave radiation, and we've been wrong all these years. It makes more sense because they're looking at the sun. They're looking to see if the sun is out. Well, no, actually, they're looking at their shadow. So I take that back. All right, so basically now we have daily weather data for that location, for the months surrounding Groundhog's Day. By the way, if you're watching this on the stream, I'm making this notebook that we're working in public. I'm going to save it right now. I'm going to copy the link, and anyone watching this, feel free to go there. You can check out the code. You can fork it and edit it all you want to. Is the site Open Weather Map? No, yeah, it's Open Meteo. Meteo? All right, so we need to modify this code a little bit because now it needs to take our daily codes. So it's going to do Punxsutawney Phil up until the dates where it actually has data, which starts in 1940. We're going to take our daily data and should we assign? Should we assign the slug to this? So now we have Punxsutawney Phil here, so we know that it's his location that we're looking at the predictions of. Yeah, I like that. I think that's good. We should also include the year, right? So we know, even though it's here in this date, 1940, it'd be nice to just have it split out. Okay, so this is like our weather data frame. I'm only doing this for Phil for the first one to test this out. And then we'll append all weather with this. Let's go ahead and take these breaks out. Yeah, let's remove these print statements. And let's add TQDM. Yeah, so we need to actually do something here, which we'll pass through. Okay, so TQDM notebook isn't working, so let's just do this so we actually see something. Oh shoot, have we gotten blocked out? So I think it's running now. It's appending this all weather. We could see if our session is running low on RAM. No, we're good. We got 30 gigs of RAM. So it's not like this data is going to explode to be too big to work with. Yeah, there. So it went through all of Punxsutawney Phil. What's the 429? Maybe that's a slowdown. Too many requests error. Okay, so we got to put a pause in it. We gotta, it's going to just give us this error for requesting too much. So if we look at the weather data, it's going to be nothing. Because we're requesting too much too often. But if we look at what it did get us, and concatenate all these together. Yeah, we got up until the year 2000. The year 2000 of Punxsutawney Phil's historic weather data. And let's make this a data frame. And what we will do is we'll add a pause to this. Import time. And like sleep for 1 second each time. And that'll be when I run it officially. So how many rows is this? How many rows is this? It's going to be 1,481 rows, 4,081 calls. I guess we're dropping anytime the shadow is null. Right? So 1,320 calls to this API. If we multiply that by 1 second, that many seconds in minutes is 22 minutes. So we're not going to sit here for 22 minutes and let that run. But the 1 second pause each time should make it so that it doesn't give us that timeout. And we did start receiving it here. But the thing is, these other guys, when we get their responses, it's not going to be, they don't have that many years. So once we get most of Punxsutawney Phil, we're good to go. Weather DF. So this code is actually good to go. It should be good to go to save off this weather data for us at a later time. But for now, we can look at this weather data from Punxsutawney Phil. So now what we can do is take this results. We can query where slug equals Punxsutawney Phil. All right. Gonna do something cool here before we end. Before we come to a close, we're gonna actually reach some sort of precipice of analysis. Set index to year. We'll take shadow. Shadow the predictor. Yeah, shadow's what's supposed to predict. That's what he predicted. That's what that little muskrat predicted. I know he's not a muskrat, but so we can map his prediction into a new column. Now it's kind of a redundant column because shadow, right, is either 1 or 0, and it's for this whole year 1940 it's going to be either a 1 or 0. But now we can do something cool. We can take Seaborn and we can do, what can we do? I guess we could do a box plot where the X is shadow and the Y is pick a feature. What do you guys think? I guess weather code or the average temperature. Let's do that. Okay. So what do we see here? The average temperature, this includes, maybe we should only include after February 2nd. So basically, pull out the month from this. And query when the month is February. We'll give them the first. We'll give them the 1st of February. It's a gimme. And only look where the month is greater than 2. Have to factor in global warming? Well, I mean, if that's the thing, then Phil's got to count for that in his forecast. So what we see here, what we're seeing here, let's make sure we're all on the same page, is a box plot. Let's do violin plot. No, let's go to boxing plot maybe. None of these are too great. But what we're seeing here is the distribution. Is this better? No. None of these. None of these are too great, but the difference between when he sees his shadow and when he doesn't. When he sees his shadow for the following month, the average temperature is slightly lower than when he doesn't see his shadow. When he sees his shadow, he goes back in. It's supposed to be more winter. So this does look like there's a little bit of a correlation between what this guy predicts. How can I get as good as you in pandas? I can't even remember basic functions. You just got to practice. Or just look it up every time you need to do something if you don't do it too often. But don't be down on yourself about it. You'll only get better the more you use it. Heatmap. Someone said Heatmap. I don't know about that. ChatGPT. Yeah, that'll help too. So, granted, this is only through the year 2000. And also keep in mind, we've looked up here and we realize that most of the time, Phil predicts there's going to be more winter. So he's biased in that way. But when he does predict that it's going to be early spring, a very slight bump, I'm sure it's not statistically significant in the difference between the weather patterns. Another way we could look at this, another way we could do this, which might be a clearer indicator, is we'll take all the weather data, we'll group by the year and the shadow, and then we'll take the average of the average temperature. Or we could take, the average of the average temperature, which is kind of weird. But now we only have one prediction per year. It's a little less granular. So this is yearly average temp. Let's call it average temp by year. Wow. If we do it this way, we're just looking at the average temperature. These really cold days, or this really cold average February and March, It does look related to his prediction. I probably compare Snowfall. We can do that. We can do that. That's the nice thing about having the data all here ready for us. By the way, I'm going to save this version. It's going to take 22 minutes to run those queries on the weather data, so I hope that works. Let's look at that. Where would the snowfall be? Let's look at the columns. Precipitation hours. Oh, snowfall sum. Okay, this will be cool. So instead of doing this average temp by year, let's do the total snowfall by year. So we'll take the snowfall sum, and instead of doing the mean, we can just sum this. Could not input. Oh, okay. So this is snowfall sum. All right. Colder might indicate winter. Yeah, so look. There is more snowfall when he predicts this weather. He sees his shadow. So I also get confused by this. So let's just make sure we have this mapped correctly. Shadow map is going to be a zero is does not see his shadow. So early spring. And 1 means long winter. I will map this to this. That's its prediction. And let's show it like that. Because I think that's a little bit easier to understand. All right, early spring, less snow, long winter, more snow. Boom. The groundhogs are correct. Actually, we only know Punxsutawney Phil. So we could do this for each of these prognosticators and see how well they do. One thing I didn't consider also is I think some of these guys don't predict on Groundhog Day necessarily. Although we are using the Groundhog Day API, so I hope they're mostly around Groundhog Day. What do you guys think? You have any feedback? What do you guys think? Anyone out there? One thing I maybe want to try here, just to see if this will work, is let's, instead of making the sleep time 1 second, let's make it like 0.1. And see if we can get more of the weather data before it starts failing out. Maybe we should... Oh, if the response is a 429... If the response is this 429, we should probably then add the sleep function, right? So Basically, if we should return response status code. If it's not a 200, and if weather data equals 429, then we sleep for 1 second. All right, so then we don't have to oversleep. Yeah, there we go. All right, so these are returning 400s. Punxsutawney Phil data coming through. Wait, so this is fail to retrieve data 429. It should then pause. What did I do wrong here? I don't see what I did wrong. Whether beavers are cooking, yeah. See, then it ended up working, so. What's this weather data come back as? I made it. Maybe this actually didn't run this. That's what's going on. Make it pause a little longer before requesting again. Yeah, so this pause isn't long enough. And I need to make it re-request when it misses, when it gets a 429. So this would be like a while weather data equals 429. We sleep. And then we still do this. Need like a while statement, which I'm always a little scared of while statements because it could run forever. All right, so it's pausing. We're attempting. It's pausing. See if it gets through. All right, so it looks like that works. And now I'm going to save this version, see if it saves all the way through. People should be able to see it. And we're going to see tomorrow what Punxsutawney Phil does. So thanks for hanging out with us. What did we do tonight? We figured out how to pull all the prognosticators, including Punxsutawney Phil's predictions historically going back in time using the groundhogday.com API. Thank you, groundhogday.api, for being a thing and letting us do that. We did that in Python. We stored it as a data frame. We stored metadata about them. We mapped where they looked, where they were on a map. We mapped the groundhogs versus the non-groundhogs. We also took a look at which of these prognosticators have predicted the most and the least. We then took a look at who predicted more spring, early spring, winter. You could see that the guys who predicted a lot of early springs happened to be in the hotter areas, at least one of the examples we looked at. Then we dug into the weather data. It wasn't too tough. We took the latitude and longitude that we had from that metadata. We went back to every year they made a prediction, and now we have code that's running and is pulling the historical weather from January, February, and March at that latitude and longitude and saving all that off as a CSV. So once this notebook is done running, we'll have all that data, and next year you can put your predictions to the test and you can do all the analysis you want. Or tomorrow after he makes his predictions, we can see how well he's done in the past and do some more analysis. But that's it for today. Thanks for hanging out, everyone. We did do a lot of stuff today, and it was all based around the most famous holiday in all of the United States. So if you're not in the United States, this is our, big days tomorrow. It's like the Super Bowl, but not really. All right. Thanks everyone for hanging out. I'm going to go ahead and end the stream. Be nice to each other, and I'll see you guys next time. Let me know, chat in the comments, share this with friends. It's going to be up on YouTube. And if you want me to stream more, let me know. If you don't want me to stream more, don't say anything, and I'll assume silence means that you hate me. All right. Thanks everyone. Have a good one. See you next time. Bye-bye.